Okay, so circumference. All right, so what are the, actually two formulas, I guess, but one's kind of a derivation of the other. So circumference means like the perimeter for a figure with no rounded sides, but it's the distance around the figure, or in this case, around the circle. So what it would mean if you had a circle and you took a string and you laid your string out around the circle and then straightened the string out and put a ruler next to it, that's what you're measuring, is that distance around that circle. And that might have been something you did back in 4th grade or 5th grade when you first learned circumference. And that's the way, well, that's what I did when I taught 3rd and 4th grade. But anyway, so you just take your, did anybody else do that? Take your string and lay it around the circle and then straighten it out, put it on a ruler, and that's how you learn how circumference is. But there are two different formulas. Anybody know?
R times 2 equals the diameter.
R squared
True.
times pi or some crap?
You've got, on a circle, you got your center.
Yeah.
That's area.
Oh.
So this, the radius is the distance from the center to the outside of the circle. The diameter is the distance from one end of the circle to the other, but it has to go.
Diameter by times the radius by 2.
Yeah, we're getting there. That's what Spring said. So the radius, you can think about it, is half of the diameter, or the diameter is twice the radius, just depending on how you want to look at it. But their circumference, to find the distance around, there's two of them, 2 pi r or pi d, pi times the diameter. Okay, so the 2r just gets substituted with the d. But you can use either one. So if they give you the diameter, you can use pi d. If they give you the radius, you use 2 pi r.
3.14, right?
Yes, that's
But
what
We
you
had
normally use.
so many formula quizzes in 7th grade for our test. It
Yeah.
was ridiculous. We had
Because you have all that, well, you're getting ready to get into that, because we're getting ready to start area and volume, surface area, that kind of stuff. So
Volume?
those old formulas are going to come back up.
Oh no, I was never good at
They're
volume.
gonna haunt me.
I sucked really bad.
Well, hopefully you'll be better this time.
No.
All right, so yes, you got to be positive, Joseph. We're being positive. We're not being mean. We're being positive.
I don't mean nobody. I'm just
We're
being
being
myself,
positive.
but I
You're going to
failed
have
today.
positive self-confidence. You can do it. Okay? Say, yes, I can.
You just believe.
Joseph, yes, I can.
No, I can't.
You feel like the Indiana longest short.
What?
You can do it. It's
All right, so on that skills practice, we've got to get through some of the like definitions and that kind of jazz. So let me draw this circle up here. And we got P. All right, so this is called, you name a circle by the, well, pretend like that's on there. You name a circle by the center. So this is called circle P. All right, so on here we've got circle P, or you can do it like that. Circle P. Did anybody watch South Park?
Yeah.
I was watching South Park last night and
You
there's,
stand up to what? 12 in the morning to watch South Park?
Those shows are
no,
great.
I don't
You
stay
know
up
what
till.
you-
Okay, so this is circle P. There's actually 3 radiuses, plural for radiuses, in this circle. A radius is a segment. So one of the radiuses, radii, is PC or CP. One of them could be PA or AP or PB or BP. Okay? So when you name the radius, it's a segment. Now there's one diameter here, and it's AB. So here's the radii, or radius, is singular, and the diameter. Now this other little segment we've got drawn over here, that's called a chord. And you should have heard of that before. A chord,
7th grade.
and this is chord DE. And it's a line that goes from one part of the circle to the other that does not go through the center. Okay? So that's just your vocabulary. So on number 1,
You pretty much named them all.
yeah, I pretty much have. Number 1, name the circle. There it is. That's what you write. Circle P. And y'all think of South Park when you see this now. Circle P.
Remember.
Stupid you.
Yeah. Name a radius. Well, we just did. Number 2. There's the radius. 3. A chord is DE. Diameter. Number 4. We got that. Name a radius not drawn as part of a diameter. PC. So there's a radius that's not drawn as part of the diameter. So that was number 5. All right, so now it says number 6. Suppose the diameter of the circle is 16 centimeters. So we're on number 6 now. So if the diameter is 16, what's the radius? 8 centimeters. Don't forget the units. Remember, if you forget that tomorrow, it's going to be wrong. Don't forget the units, 8 centimeters. All right, if PC is 11 inches, so I'm on number 7. I'm going pretty quick here. If PC is 11 inches, well in this, PC is the radius, right?
R.
PC is the radius. What's AB, the diameter?
22 inches.
Do what?
22 inches.
22. 11 times 2. So AB is 22. Don't forget the units, inches. Okay, so are we good on all that? Do we need to close the door? Who's outside the door?
I don't know.
Obama,
People
trash guy.
walking by.
Obama. What's he doing here?
Everybody good? 1 through 7?
Miss Touchdown, can you circle, like, make arrows to which one is which? So I can get it there.
Yes, I can. Thank you for asking. All right. Radius. Here, here, and here. PC, PA, PB. From the center to the outside. Okay, so those are the radiuses. Just remember, radius is the center to the outside.
So it's actually called a radii.
Radii is plural for radius.
So it's like a pulsi and cacti and
Yep.
all that stupid Canadian stuff.
Something like that. All right, you get on that one? Okay, so the diameter is this one. So there's the diameter. It goes from one end of the circle to the other, but the key, through the center. I said, this is exactly what I'm talking about. If you hadn't asked me that, I would just have assumed everybody knew exactly what I was talking about. And I'd have gone right on, so you gotta let me know. All right, so we're good there? All right, let's see if I can find a different color here. We'll do black, I guess. All right, a chord is right here, DE. There's a chord.
I can't tell what color the words are drawn in.
Are you colorblind? Or you just can't see?
I just can't see because the light's all over.
Oh, okay. All right, a chord is just a segment from one end of the circle to the other. It can go through the center, but it doesn't have to. So technically there's two chords here. There's DE and there's AB. But you don't always think about the diameter as being a chord.
Yeah. There's usually a separate one.
Normally they'll draw chords that are not going through the center. But technically AB is a chord.
So if they don't have one off to the side and they ask for a chord, you just put the diameter
The
as well?
diameter, yes.
On our homework, do you have to name one through every radius or just one?
You'll have 3 radius, 3 chords, 1 diameter. As soon as we get there, let me get through these next ones and then we'll go through the homework and I'll tell you how many. Will that help?
Yeah.
Okay. All right, so numbers 8 and 9. Well, I cannot draw.
Don't feel bad, I can't. I'm even taking part 1 and I'm still bad.
Well, pretend like it's a circle. It looks like an egg, but pretend like it's a circle.
It's a circle to me.
I'm trying to draw.
Yeah, my sister dropped one.
Alright, so here's A. Alright, so we've got circle B and circle G. So circle B is the little circle. Circle G is the big circle. We good over that? Okay. So now it says the diameters of oh, it's not circle B, it's circle F, sorry. Circle F. Well, pretend like F is in the center of that circle. To me, I thought it was B, but okay. So the diameters of circle F and G are 5 and 6. So circle's F diameter is 5. Circle G diameter is 6. So that means that from here to here is how long? What's the radius of circle G? If the diameter is 6, the radius is 3. Okay, so that means from here to here is 3. And it also means from here to here is 3, right?
Yeah.
We are.
Okay, so if I just kind of draw from there to there, that's also 3. Circle's F's diameter, which is, remember, circle the F. This is F. So this this radius, the diameter is 5, so the radius is
2.5.
half of that, so 2.5. Okay, so this little distance right here is 2.5. So now we know that distance in the middle there. Because if from B to G is 3, and I take off that 2.5, how much do I have left right there?
0.5.
0.5. Does that make sense?
Yeah.
If from here to here, from B to G is 3, and then from F to G is 2.5, so that little distance right there is 0.5, because all the way from B to G has to be,
We just
So-
put units.
yeah. Okay, so now, number 8, they want us to find BF. All right, so we just did that. So BF, does everybody understand where I got the 0.5? Just
Yeah.
subtracted 3 minus 2.5. Okay. So B is 0.5 units, and you can just put U, or you can write out units if you want. So now AB, well, they told us this radius, this whole thing, was 5, correct? Okay, so we know from here to here is 3,
Yes.
so 5 minus 3 is going to be
2.
2. So this one is 2. So AB is 2 units. Good.
Is that a U or an A?
U, just for units. You can write out units if you want. We good now?
Yeah.
Okay, all right, so next one. So 10, all right, find the radius, diameter, or circumference. All right, so number 10, they tell us the radius is 8 centimeters. So what's the diameter?
16.
16 centimeters times 2. Now, do they say what to use for pi? Oh, they say go to the missing, find the missing measures to the nearest hundredth. So here's what we've got to decide. There's a pi button on your calculator, or we can just say we're going to use 3.14.
Yeah.
So what do you want to use?
I don't see
We
the pi
usually
button.
just
The
did
pi button is
3.14.
above it's on the right side, like right below the arrows
Oh, I
or
see
somewhere
it
right
now.
in there.
In
Like-
7th
Seconds
grade,
to
we
do
just
it.
did 3.14.
Okay, so is everybody good with 3.14? All right, so we're going to use 3.14. So for the circumference, you can
3.15.
remember it's 2 pi r or pi d. So you can either say 2 times 8 times 3.14, or you can say 16 times 3.14. It's going to give you the same thing, but how you get there is your choice.
50.14.
And it says the nearest hundredth, so that's 2 decimal places.
So it would be 50.44. So
I don't have a,
Yeah.
Did everybody else get that?
50.24 because it doesn't go on.
okay, so 50.24, what?
That's it.
Then that means
It just
they're-
ends?
Centimeters.
Centimeters, 50.24 centimeters. Alright, so 11 gave us the radius again, so same thing. So the radius is 13 feet.
26 feet.
Okay, so the diameter times 2, 13 times 2,
81.64.
so 26 feet. Circumference, I'm just going to say 2 times 13 times 3.14. And what'd y'all get?
81.64.
Yeah, 81.64.
Yeah.
You got it?
Yeah.
Okay, anybody else? Still right? Okay, go ahead. 81.64 feet.
Okay. After working ahead, now I'm on 13 and I'm really stuck.
Oh, you'll be fine.
You just gotta work backwards.
So 12,
I don't do that.
do I need to stop and let you catch up, or am I good?
You're good.
Good, okay, all right, so on 12, the diameter is 9 meters, so we gotta work backwards. So divide 9 by 2, and we get 4.5 meters for the radius. So you're dividing by 2. And when we do the circumference, I'm just gonna use the diameter, because that's what they gave me. So 9 times 3.14,
28.26.
Meters.
28.6,
26.
26. Did everybody else get that?
I did.
9 times 3.14, 28.26. You good? Okay. All right, now here's 13. So this time they gave us the circumference, so we've got to work backwards. So remember, here's our equations, 2 pi r and pi d.
It's easier to start with the
So if we do the circumference, that's what they gave us. Remember, if this is the circumference, all we got to do is divide by pi, and it'll give us the diameter. So if you say 35 point, I'm going to say d equals 35.7 divided by 3.14. Y'all decided to use 3.14 instead of pi.
Yeah, you get 11.369 or 11.36.
2 decimals.
11.37.
36. Well, it would round to
It would.
4.
Yeah.
No, 2 decimals, not
Yeah.
1. 3.
3.36.
Well, what's the third decimal?
9.
So it's a 7. Because the 9 rounds the 6 up. And that's going to be inches.
And then your
And
radius
then
is
we
5.6.
divide that by 2 to get your radius. Now you got to be careful though. If we're going to use 11.37, you're going to have to say 11.37. Don't just say divide by 2 in your calculator, because your calculator is using all those decimals.
Yeah.
So be careful. Use 11.37 divided by 2.
It'll be 5.69 is what it rounds to.
Yeah.
5.69? Okay.
It would be 5.7 if we were rounding up by like.
If we were rounded to tenths, it would. Alright, we got that?
No.
Yes.
Now, I hate to inform y'all of this, but now we're coming back to that 45, 45, 90, 30, 60, 90 stuff.
The bottom was actually kind of easy. 15 squared plus 8
So
squared.
we'll have to write all that stuff down just so you have it. Do what?
Is this all we're gonna learn today?
Yeah.
It's actually
It's not
really
that far.
easy.
This, like I said, this is high.
What are you doing?
Are we good?
No.
Hello. How are you?
Just walking around.
Walking around doing nothing?
Just being busy. This is pretty whole class.
We're missing 3 people today. And I guess I've scared them off.
You probably have.
Plus 3 squared gives you
Yeah.
9.
You through, Tyler? Okay, all right, so now, Carly, I know you have all that stuff because that's what we were working on. Would you care to get this out just so we can write it down? Now, remember we had you should have this in your notes, but I'm going to write it up here again. So on a 45, 45, 90, we've got the triangle. Because those two angles are equal, the 45 and 45, that means the two legs of the triangle are equal. So this is the hypotenuse.
It was that
So
one
to
and
find the, let me get them all out.
3 squared plus.
And like I said, you should have this in your notes, but we're just going to put it in here so you'll have it fresh. So to find the hypotenuse, or we'll say to find one of the legs,
The diameter.
well, just with this, first. To
45,
find the legs and to find the hypotenuse. All right, Carly, I know you got this in your notes. So to find the hypotenuse, what do we do?
it's the square root of 2 times the leg.
Times the leg, okay? So if you were given the leg, then the hypotenuse is the square root of 2 times the leg. So vice versa, if you're looking for the leg, it's the hypotenuse divided by the square root of 2. So that was our 45, 45, 90.
How are we supposed to find the hypotenuse then?
Well, you're not on this one. I'm just writing these formulas down for you. Then we did our 30, 60, because this is what you took your test on last week. So on our 30, this was the special right triangles. I think it was 7-4
Oh, I missed really
or
bad.
7-3. Something, one of those two. 7-3, 7-4 was tricks. This was 7-3. So remember on the 30, 60, 90, you've got to, I wrote those backwards. This one is 60, this one is 30. So you got a short leg, a long leg, and the hypotenuse. So the hypotenuse is always across from the 90. The short leg is across from the smallest angle, so 30, so this is the short leg. The long leg is across from the 60. All right, Carly, tell us what our equations were for that.
The long leg is square root of 3 times the short leg. And then for the hypotenuse, it's 2 times the short leg.
Okay, wait a minute.
The hypotenuse.
Oh, I thought you were going to give me the long leg and hypotenuse next. I think it's down at the bottom.
Is it the
Square root of 3 over 2 or something, I believe.
Yeah, square root of 3 times the hypotenuse over 2.
Okay, so if you're looking for the long leg, given the short leg, that's your equation. Looking for the long leg, given the hypotenuse, that's your equation. And then remember we had 2 equations for the long leg, 2 for the short leg, and 2 for the hypotenuse. All right, so Carly, short leg.
Then, is it the hypotenuse equals 2 times the short leg?
No, we're looking for the ones with the short leg.
Oh,
The ones that say SL equals.
hypotenuse over 2 divided
Okay.
2. And then, long leg divided by square root of 3.
Okay. All right, so if you're looking for the short leg, then those are your 2 equations. And again, you should have these in your notes here. Then we had 2 more. You had the hypotenuse. So if you're given the short leg and looking for the hypotenuse, then you've got 2 times the short leg, right?
I don't know.
Oh, I was waiting on Carly.
Oh, what?
But she's got them. The hypotenuse is 2 times the short leg.
Is it hypotenuse equals 2 times the long leg?
Oh, wait a minute. It's long leg, sorry. That is my fault. Long leg, that one's the square root of,
Yeah, divided by the...
yeah, that's my fault. And I erased the 2. Well, I swear. Square root of 3 divided by, what is it? The hypotenuse equals, you're looking for the one with the hypotenuse and the short leg.
Equals 2 times the short leg. That's the one you have.
This is what I had to begin with.
Yeah, that's what our notes.
But then you said you had this one. Shouldn't this one be the square root of 3?
Oh,
This
yeah.
one should be 2
Yeah.
long leg divided by square root of 3.
Yeah, that was square root of 3.
Yeah. So this one's 2 long leg divided by square root of 3.
Yeah.
Okay, now, I had to get back to those so we can do the last two problems, 14 and 15.
They're easy.
Okay? So, there we go. So we've got a circle circumscribed around a square, or a square inscribed in the circle, however you want to think about that. So you have this line, which, what is that line? It goes through the center of the circle, so that's the diameter of the circle. It's also a diagonal on the square. These little marks here, that tells us that, in which we knew this, all sides in the square are the same. So that tells us if these two are the same, then this is a 45, 45, 90, because we know a square has 90-degree angles. And if that's an isosceles triangle,
The base
so that's 45 and 45, because the base angles are equal and the legs are equal. So that's all they gave us, and said this was 3 centimeters, right?
Yeah.
Okay. Now, find the exact circumference of each circle. When they say exact, they don't want you to divide by pi. I'll show you what they're talking about. So, circumference equals 2 pi r or pi d, right? Right, so, did they give us a radius or did they give us the diameter? No, they didn't give us either one, did they?
They give you a quarter.
But if we know this is 3, we know this is 3. This is a right triangle, so we could use Pythagorean theorem if we wanted to. Or we could go back to this and say, oh, well, I know the hypotenuse is the square root of 2 times the leg. So this is the hypotenuse. This is the leg. Well, you could, but they want an exact answer. So that's why they don't want you to use Pythagorean theorem. So we're going to use this equation right here. Hypotenuse is square root of 2 times the leg. So we're going to say, okay, the hypotenuse is square root of 2 times the leg. Which in this case, our hypotenuse is our diameter, right?
Yes.
Okay. Yep, it is. So we're going to leave that pi in there. We're not multiplying by pi. So we're going to say pi times the square root of 2. And what's the length of the leg? 3. Units are going to be centimeters, and really that 3 should be up front. We really want this to be 3 pi square root 2. And you leave it just like that. They don't want a decimal answer. So you leave it just like that, 3 pi square root of 2.
Makes sense.
Okay? Alright, now the next one, let's see, we've got a rectangle. This is our last one, isn't it?
Yes.
Alright, so we've got a rectangle and a circle. That's my beautiful drawing skills again.
It's like an oval.
Yeah. Okay. Anyway, so we've got a rectangle. But they've drawn the diagonal on the rectangle, but that's also the diameter of the circle. Let's say 8.
Yeah.
8 and 15. Alright, so this is 8, this is 15.
Are all sides the same?
No, because that one's 8 and that one's 15.
Well, both of the short sides would be the same.
You know, this one's, I mean, this side, is that what you're asking me? Or opposite? Yeah, opposite sides are the same. So that one's 8, that one's 15. Okay, so we've got that. Anything else we know?
It's a 30, 60, 90.
It is a 30, 60, 90.
So that means it's going to be harder?
No, I mean, we've got our, so let's just use this bottom one. So this one's the 90. Remember, the 30 is across from the short side, so that means this one's the 30 and this one is the 60. What do we need to do now? This is the hypotenuse, right?
Yes.
Okay, so let's go back to our equations. Which one's the easiest one to work with when we're trying to find the hypotenuse?
The short leg.
This one, 2 times the short leg. Okay, so I'm gonna write this down. Hypotenuse equals 2 times the short leg. All right, well, what's the short leg? 8. So we've got the hypotenuse, which is also the diameter. So 2 times 8, which is 16 feet. Okay, but that's not what they asked us for. They asked us for the circumference, right? I didn't finish this one, did I? No, we did, circumference, okay. So now circumference, pi d,
Yes.
so pi times 16 times pi feet, because that's our diameter, right? And we leave it like this, because they said exact, so we leave it like that, and we're done. That's it. You got that? This actually has both of your homework for today and tomorrow, so tomorrow we'll grade these and then we'll do the next page. And remember, Jackson, I think it was Jackson, asked me to which one, how many are on each one.
Oh, yeah.
So as soon as I give all these out, I'll tell you how many answers are on each one, so you won't miss any of those. All right, so number 1 has 1 answer. 2 has 3 answers. And remember, these are going to be segments. Oh, that's not that one. Not that one. This is what we were doing here. Segments, you name the circle like this, the segments with the bar over them like that. So 2 has 3 answers. 3 has 3 answers.
Do you want us to give all of them?
Yes. Yeah, 3 has 3 answers. Everything else has 1 answer to it. Don't forget the units. Remember, if you forget the units, it's wrong. Don't forget the units. So 6, 7, 8, 9. Well, everything from 6 down has units.
So from 4 down, there's only 1 answer?
4, 5, and 6. Well, besides like number 10 where they give you 2 parts.
Yeah.
Yeah. They all have 1 answer. So 2 and 3 are the only ones that have 3 answers. Everything else has 1 answer.
Does number 3 also include the answer to number 4?
It could be, yes. Number 3's answer is also a number 4 because we talked about a chord can be a diameter.
Alright.
Okay, you got till 10:15, so you got 20-something minutes. So you can get a lot of this done, and we can get those checked while you're at it.